is less than 1.3, the natural log of ln. So we have an E ruler's number. So E ruler is the dude that came up with this, just like Pythagoras was the mathematician that came up with the Pythagorean theorem. This is Euler. Okay, so Euler came up, he's a famous mathematician, he came up with the natural log. We don't have to know how to calculate it in nature because it's an irrational number. We'll never be able to figure out how it's calculated in nature. But it does exist in nature, so which is why we do the log space. So here's our natural log. So whenever we have an exponential function, this is our basic exponential. So we have our basic exponential function, and the coefficient in front of the letter E is a 1. It's a hiding 1. That coefficient is always your y-intercept, okay, of your graph. So it's going to touch at positive 1. So it's showing you here, there's the positive 1, okay? And that positive 1 is the y-intercept. So it says that A must be a positive number because it says it's greater than 0. So that means the A number has to be positive. Now what it means A and B, it means A is the coefficient and B is your base number. Well, in this case, our base is the variable E for our natural log. The A number is our y-intercept. In this case, it's a 1. So they're telling us y-intercept has to be bigger than 0. So far we're good. And it says B has to be larger than 0. Well, if our base number is letter E, and letter E is 2.7 yada yada, well, we already know that 2 is bigger than 0, so we have made sure that these parameters are in place. Okay, they are true. So now we take a look. It tells us A is 1. Yes, A is 1. It tells us what B is. Now, how do we solve these types of equations? We solve them identically as we would solve any other same base equation. If they're going to have an E equation, an E as a base, you're going to have E on both sides. Or they will have it where you can switch it right to log. So we'll do both of those. So this question right here, 2 E's, I would drop my E's. And now I'm back to solving. So I would have 2x equals 6x minus 10. Now I'm going to take my x to the left. So my 6x's come over to the left by subtracting 6x. And I subtract 6x over here. That's going to give me a total of negative 4x's equals a negative 10. And that's going to give me a positive answer because the negative is going to divide out a negative. So we're going to take 10 and divide it by 4. How big is 10 divided by 4? We're going to get a decimal. Yeah, x equals 2.5. Okay, so it equals 2.5. All right, we're going to type in a couple different things in our calculators, and then we're going to solve them. So, back to our calculator. Okay, so we're going to type in a couple values. We want to see if they're equivalent. So, if I write the word log, what is my base? 10. If I write the word log, what is my base? E. Okay. So, log base E of 5. Let's take a look and see what that would give me. So, since I've got the calculator that will not do log base, I don't have that button, I have to type it in a different way. I need to type in log of my big number. So I'm going to go log 5 divide by log of E exponent 1. So you always have to put that exponent in there. And if you don't see one, it's always a 1. So I need to type this in exactly as I see it. And remember, the word log is going to open a bracket with some calculators, which means you've got to close that bracket behind it. So I'm going to type in log 5, close my bracket, divided by log, now I need that E, and that E is above log, but it's yellow, so I have to take yellow, E, exponent 1, close that bracket.
But you might have to double close?
We don't, because there's something else coming after it. It'll still give us the same answer, but if you double close, you're fine. Okay, so it's going to give us 1.61. okay, or 1.609. But we're going to type in the exact same thing, because we know that the word lawn already has that invisible E for a base. So we're going to go to our calculator, and we're now going to type in just lawn 5. So now I'm going to type in lawn 5, enter. And I get the exact same answer. So we're making a conclusion here. Our conclusion states that if we have a base E, log base E is identical to saying lawn. Okay? And that's basically what it's telling us. Now, can we solve anything with lawn if we put log base E? Absolutely. Do we have to? Nope. Because lawn works the exact same way. So, in this case, if I wanted to do a conversion, we're going to convert, and then we're going to go to natural log. So, if I'm going to convert to natural log, in order for me to convert in log form, I always have to write the word log first. But instead, we're not going to write log, we're going to write lawn. So I write lawn first. Now, where's my base? E. Well, lawn already has a base E, so do I need to write the base E? Nope. And now the X and the 2 switch places. So it's going to be lawn, which has a hidden base E, so I didn't draw the base E in. I'm just going to put this in red there. That means it's already there. You don't have to put it there. Okay, equals X. So now all we have to do in our calculator is type in log 2, enter. Okay, so type in log 2, see what you get. Two decimal places. Sorry. You get log 2. What'd you get, sorry? 0.69? Let me just check, because I think I have the wrong answer. Log 2. Yep, 0.69. We're all right. Okay, so this guy equals log 2, so x equals 0.69. We're going to do the exact same thing to the next one. Okay, next example. We are going to put the word lawn. It has a base E, so we are going to switch those guys places. Lawn 3 equals x plus 1. Now, how do I get rid of that 1 on the right-hand side? You're going to subtract 1. So I'm going to subtract 1 to that side. And just like we did with the word log, we put this number in front of it and connected it with a plus sign. So it's going to equal negative 1 plus log 3 equals x. Okay, and that's the way you have to type it in. So we go to our calculator now. And we type in negative 1 plus log 3. Now, you could have also typed in log 3, enter, plus negative 1. Okay, both are correct. So, to 2 decimal places, the 8 after the 9 is going to round the 9 to a 10. So it's going to end up 0.10. Okay, so x equals 0.10. So x equals 0.10. Alrighty. The next question is this guy here. Do you see something crowding the letter E? Yes, the 2's crowding him. Whenever you've got to isolate your base, he's got to be by himself, the base and exponent. Everything else has to be removed from that side. So we need to take that 2 and take it over to the right-hand side. So we are going to subtract 2 to both sides, and that's going to get rid of it for us. So we're going to get e exponent 2x equals 6. I'm just going to erase everything on the left-hand side here. Okay, so e to the 2x equals 6. That's what we're going to get first of all. Okay, and that's for letter C. Now, how do I get rid of the base e? Log it, right? You want to get rid of that base, you have to log it. Whenever I want to get rid of base 10, I log it. So I have to get rid of base e, so I log. So log, let's see, a base e, these guys switch places. So ln 6 equals 2x. Now how do I get rid of what's crowding x? Divide by 2. So we're going to get x equals ln 6 divided by 2. So how big is x? It's going to round again. It's one of those situations where it's going to be a double round, so it's going to be 0.90. Okay? Because you end up getting 0.895, yada, yada, yada. And if we want 2 decimal places, this guy rounds him up. Okay? That's how that works. Okay, so we've dealt with ln. We know how to deal with it with a basic conversion, with something being added to it, with something being multiplied to it. So now we're going to go over, we're going to take a couple questions and see how we do on those. So letter D, E, and F. They each have a couple more steps. So, first thing I'm going to do, the first question is I'm going to ln it, of course. So I'm going to ln, and then these guys switch places. Ln of 1 equals, and I can't hide that one, I actually have to show it, I don't know why I'm dotting it, equals 2y. Now how am I going to get rid of that 2? Divide it out. So you're going to get y equals ln 1 divided by 2. So you literally type in ln 1 divided by 2. It's kind of a trick question. It gives you 0. It should give you 0. If you type in ln 1, gives you 0. Divided by 2, still gives you 0. Okay? So if I type in, take a look at your calculator, you go ln 1, enter, 0. Divide by 2, enter, 0. Now there's a reason, and we're going to get into log laws in the next lesson. Okay, we're starting on today. But the reason we need just the basics right now, okay, we're just doing converting right now. But this is a log law. Any base exponent 0 gives a 1. Okay, if you remember your exponent laws, if I've got 5 exponent 0, 1, x exponent 0, 1, e exponent 0, 1. And if you convert it to exponential form, this is e exponent 0 equals 1. Okay, so that's why it works, because it's the exponential rule. Okay. All right, so that's the first one there. Let's take a look at letter E now. Letter E has a couple things going on. So we're going to convert first. So I'm going to put this guy on the other side, 2.5. I don't like him over here. And now I'm going to write ln. So ln of 2.5 equals 3x plus 3. So this one has 2 extra steps now. So I can't solve it yet. What do I have to do to that question to isolate x? Forget that it even says ln on the other side. What if the word ln wasn't there and you just had 2.5? How do you get rid of that 3 there? You take it to the other side by doing the opposite function. Right now he's being added. You're going to subtract 3. Now remember, you're putting it out front. You're going to write it in front of the word ln, connect it with a plus sign. So we're going to have negative 3 plus ln 2.5 equals 3x. Okay, that's what we have so far. Last step, what do we have to do now? Divide it all by 3. So now we're going to divide everything by 3 to get rid of the coefficient in front of x. So if they wanted an exact value form where the decimal's not rounded, this would be our exact value form. Okay, because often you're asked for an exact value form. So this is considered exact value form before you punch it in your calculator. Okay, that's what that means. So now we're going to punch it in. What do you get for an answer? Yeah, negative 0.69, which rounds up to negative 0.7. So x equals negative 0.69. Okay, that's for letter E. Okay. We're going to tackle letter F in a moment. I'll just give you a moment to write that down. Okay, we're going to tackle letter F now. We always need to have the variable isolated. If you look at letter F, it is not isolated. So we need to move the 4 over first. It's always reverse BEDMAS. So we're going to add 4. We're going to add 4. So then we're going to get 2 e exponent 2x plus 1 equals 4. Now we need to get the e by itself again. It's being multiplied by a 2. How do I remove that? Divide it out. So we're going to divide out the 2, divide out the 2. So now we've got e to the 2x plus 1 equals 2. Okay, next step, the base is isolated. Now you log it. So we're going to hit log, and this and the 2 switch places. Okay, so log 2 equals 2x plus 1. Now we got to take the 1 away. What do we do with the 1? We're going to subtract it, and it's going to go out front the word log. Subtract 1, minus 1, connect to the plus side. Okay? How do I get rid of that 2? Divide it all by 2 now. Okay? So the 1's gone. Now we're dividing by 2 to everything. Now, if you want to do it all in one step, this is what you'd have to type in. You need brackets. So I would open a bracket. I would type in -1 plus ln 2. But take a look on my calculator, ln opens a bracket. So I have to close that bracket. Now, this whole top is the top of my fraction. The top of a fraction always has to be in brackets. So I open this bracket, I now have to close it. So it's going to look like a double close here. Okay? And then you divide by 2. Okay? If you don't double close that bracket, it's only going to divide the ln 2 by 2. Okay? So -0.15 is what we should get. Okay? -0.15. So x equals -0.15. Yes.
Can I ask why you don't put those two, like this times 2 is such that?
Why we don't?
Yeah.
Because we're trying to isolate the base. So we want the base by itself so we can solve it. So it's like having a question like this. So if I've got 7 times 3 to the 5x equals 21. Okay? I want this by itself so that I can solve for that x. So you always have to divide that out. I would never times it in. You're not able to. That's not the correct BEDMAS. Okay? So it goes back to BEDMAS. You have to divide it out to isolate. Okay? Always, always. Very good question, though. Because a lot of people will forget that. Okay. We're still recording. Excellent. All right. Big gap there. Oh, well. Okay, let's take a look at the bottom here. Now we're converting back. Now we're going to go to base e. We want to get rid of the word log. So to get rid of the word log, we base e both sides. So, I'll show you what that looks like. Send. All right. So the first one, and draw it in so you don't forget he's there. He's got a little base e. Okay? So the first thing we're going to do is we're going to put that base e back. So just like we used to erase the word log, we erase the word ln and x in 2 switch places. So this is going to be e exponent 2 equals x. Okay, so we're converting backwards the other way. So e exponent 2 equals x. And now we grab our handy dandy calculator and we type in e exponent 2. So second ln exponent 2. We get 7.39. Right? So x equals 7.39. Okay? Is that going okay? All right. Next question. The next one, we have something crowding our log. We want to make sure we isolate our log or long sentence. If something being subtracted, we're going to add it out to the other side. So now we get ln x equals 3. Now we're able to change it back to exponential. So base e exponent 3 equals x. That's how we get rid of the word log. And then these two switch places. That's what's going on. The minute you get rid of the word log, you have to put that base e. Okay, that's what happens. So now we're going to type in e exponent 3, and that will be equal to x. So how big is x? Good, 20.1 or 20.09. Okay? The next one, we've got a few things we have to do. We got to take the 1 over, we got to divide a 3 out. So how do we move that 1? Subtract it. So subtract 1, subtract 1. 3 ln x equals 9. Now what should you do to that number? You got to divide by 3 again. You're dividing by 3 because it's attached to that word. And when it's attached, it means multiply. So you need to divide it out. Divide it out. Okay? So we're going to get ln x equals 3. So to get rid of that word ln, cross it off, and we put e, and we trade these guys places. E exponent 3 equals x. Same answer as B, 20.09. Didn't realize I had 2 the same. But oh well. I do have 3 the same, you're right. You did it right. Okay, letter D, E, and F. I want you to give a try on your own. I'll push pause now and play when you're ready. Okay, we've got a few minutes to look at them. So D is equal to E exponent 4. E exponent 4, 54.60 is what we should get. No, we're always rounding to 1 decimal place, minimum 1. 2 is more accurate, okay? Now, a few people ask, how do you check your work? Well, how you check your work is this. The answer you get, put it in where the x is, and see if the left side equals the right side. So right now, if I type in, on my calculator, if I type in ln 54.6, I want to get an answer of 4, or close to 4 that rounds up. So this one gives me 4 and a little bit extra. And again, remember, it's because this is a rounded decimal. Okay? So that's how you check your work. Okay? All right, let's look at the next one, letter E. Letter E. So we're dividing out the 2 first. So we're going to get ln of z equals 11. Okay, ln of z equals 11. So now we're going to switch forms. We're going to go to exponentials. So these 2 switch places. I get rid of ln, and I say E11 equals z. And it's a big number. It is 5 digits, I believe. So z is 59,874.14. Okay, so it's a big, big number. And again, we can check our work by going in our calculators. I'm going to type in 2 times ln. I'm going to type this number in. 59,874.14. And I want to get an answer of 22. And it's close. 21.999999. Okay? So that's how you can also check your work. All right, last question. A couple things going on. We have to move the 6 over, and then we got to divide the 2 out. So I'm going to put the equal sign on the other side. I'm going to erase all this stuff. Make sure you've got it written down. It's going away. Okay. On here, equal sign to the other side. Negative 6 is coming over by adding 6. So I'm going to get 2 ln x equals 6. We need to divide out the 2. Pay attention, please. ln x equals 3. Now we're able to switch forms again. So, convert e exponent 3 equals x. Remember, this guy disappears, and they switch places. Okay, that's all it is. It's a switcheroo. And now we type in e exponent 3, which is 20.09. All right. So where do we have this kind of question? The bottom one? That's where we're going. Okay. So where do we use this stuff in the real world? Well, they use it in analyzing data. Like I said, it's a natural log. So this is a problem-solving question. And it says, over the last 10 years, the amount of money in capital M, billions of dollars, spent in North America by car dealerships just for their advertising. Okay, the amount of money they spend on advertising can be modeled by that equation. Now, 0, okay, times 0 represents the year 2000. So it wants to know what year were there about $3 billion worth of money spent on advertising. So we would put a 3 right where the M is, and we're going to solve for it, okay? So if we put a 3 there, the first thing that has to happen is that 0.78 has to go to the other side. So we're going to subtract out the 0.78 to both sides. Okay, and we rewrite our equation. That's going to give us 2.22 equals 0.15 e to the 0.3x. Now, is our base e isolated by itself? Nope. So how do I get it by itself? That's right, we need to divide out the 0.15. So, both sides are going to divide by the 0.15. And then we can do our conversion. Okay, so I've got e to the 0.3x equals 14.8. That's what we should get. So, whenever the exponent is way up top, we want to get the exponent down. Just like when we use log questions, we wanted to get our bases down. But the only way to get this x from the exponent is to ln it. That's why we do these. So, we need to ln both sides. That gets rid of it. So what that means is this. We are going to ln and do a switcheroo. So these switch places. We get rid of the e, and we say ln 14.8 equals 0.3x. It's just the switcheroo. And now we have one step left. What step would that be? Calculator. You got to divide out what's sitting beside x. Right now we got 0.3 sitting beside x. So we need to divide that out to both sides. So in your calculator, you can do it all in one step as long as you close your bracket after ln. So don't forget, like I said, close those brackets after ln. You can do it all in one step. So how big to 2 decimal places? We're actually finding a year. So how big is x? Did everybody get that for x? Okay, so that's roughly, we're going to round to the nearest year. So that's 9 years after 2000. So that means what year did they spend all that money? In the year 2000. In the year 2009. So you're going to take the year 2000 plus the 9 years. Okay? So the year they spent it all in was 2009. Okay? 2009. This concludes lesson 1.3 on natural log.